When we're using addition or elimination to solve a system of equations, our goal is to get opposites in front of one of the variables. If we have opposites, they'll subtract out to 0, and we can find out what value for x and what value for y makes both equations true. However, sometimes we have to do some work to get opposites by multiplying one of the equations by something. And even other times, we may have to multiply both equations by something to get opposites. If we're multiplying both equations, the opposite we look for is usually the least common multiple of both coefficients. So for example, if I look at example 1, negative 6x plus 4y equals 26, and 4x minus 7y equals negative 13. If I look at the x's, we can't multiply 4 by something to get 6. Looking at the y's, we can't multiply the 4 by something to get 7, at least not easily. So basically, we can just pick one of the variables, and we're going to force ourselves to get opposites. So let's look at the x's. 4x and negative 6x. What is the least common multiple of 4 and 6? They both divide evenly into 12. I could easily get these to become 12 and negative 12. Since we already have a negative on the first equation, let's multiply it by 2 on both sides. That'll give us negative 12x. There's that 12 we wanted. Plus 8y equals 52. The second equation to become positive 12, because we already have the negative, we need to multiply the 4 by 3. So we'll multiply both sides by 3, again making sure we distribute the 3 to get positive 12x minus 21y equals negative 39. And now we got those opposites we were looking for, 12x and negative 12x. Adding them together, the 12x's are gone, and we're left with negative 13y equals 52 minus 39 is 13. Finally, to get the y alone, we have to divide both sides by negative 13. Y is equal to negative 1. Now we just have to go back and find x. Again, we can go to either of the original equations. I like the one with the smaller numbers, so that's probably the second equation this time. I'll just put it down here. 4x minus 7y, which is negative 1, equals negative 13. Multiplying together, simplify before we solve. 4x plus 7 equals negative 13. Subtract 7 from both sides. 4x is equal to negative 20. And finally, divide both sides by 4 to get our x is equal to negative 5. Our final solution then as an xy pair, x is negative 5 when y is negative 1. We have our solution. Let's try one more problem where we have to do a little bit of work to get those opposites. We picked on y last time. Let's pick on, we picked on x last time. Let's pick on y this time. There's no reason we can't. So let's try and get opposites in front of the y. 7 and 5. The least common multiple there is 35, so we'll have to multiply the first equation by 5 on both sides. That gives us 15x plus 35y equals 10 when we distribute the 5 through. The second equation to get 35, we have to multiply by 7. But if we do that, we'll have 35y and 35y. Neither one's negative. One of them has to be negative. So let's make this negative 7 on both sides. That'll force the negative that we're looking for. That's going to give us negative 70x minus 35y equals negative 210. Now we have opposites in front of the y like we wanted. They subtract out to 0, and we get negative 55x equals negative 200. Oh, Backing up, negative 30 times negative 7 should be positive 210. That makes it positive 220. Sorry about that. Now to get the x by itself, we divide by negative 55 on both sides, and x is equal to negative 4. Now we just have to go back and find y, which we can do by going back to either equations. The first equation has smaller numbers, so I like to go there. The first equation, 3x, 3 times negative 4 plus 7y equals 2. 3 times negative 4 is negative 12 plus 7y equals 2. Adding 12 to both sides, 7y equals 14. Dividing by 7, y is equal to 2. Our final answer as an xy pair, negative 4, comma 2. When x is negative 4, y is 2, and both of our equations are true equations.